Oops, I was not streaming on YouTube. Now I am streaming on YouTube. So should be able to join on YouTube. Make sure you have your calculator, your FE uh, reference manual handy, as well as something to write with. So we will be going through practice problems and just want to make sure you guys are able to follow along. Don't forget to put your name and where you're from in the chat. And we'll get started here shortly. How's everyone doing today? So yeah, if you search for Degree to PE on YouTube, you should find the channel and you should be able to see the live stream. We will be going through practice problems on YouTube Live. If you want to be able to see my screen, go ahead and join on YouTube. Don't forget, if you guys are liking this content, you're liking the lives, make sure that you like it. You share it with your civil engineering friends so that we can all pass the FE exam. Preferably on the first try, right? Mm-hmm. So the FE exam is for, someone asked on TikTok if the FE exam is for civil engineers. You will see a lot of civil engineers pursuing professional licensure just because to construct anything here in the States, a professional engineer has to sign off on those plans. And the first step to being able to sign off on plans is to pass your FE. But the FE is also given for other disciplines like electrical engineering, environmental engineering, geotechnical, structural, I believe. But I'm tailoring these sessions mostly towards civil engineers just because I'm a civil engineer. But yeah, I know there are some other disciplines that can take it. Thank you guys for liking the live. Um, if you're joining on TikTok, make sure you hop over to YouTube if you actually want to be able to see my screen as I work through practice problems. TikTok does not let me stream, unfortunately, so from my iPad specifically. So yeah, you can search Degree to PE online. And you should be able to find the live stream. But yeah, thank you for liking the live, Ahmed. Happy to have you here today. Usually Thursdays are the days where we have the most people show up. Again, I'm having my iPad problem again. So let me try to reconnect it. How's everyone doing today? It's Thursday, tomorrow's Friday. Anyone have any fun plans for the weekend? Nice, John. Nice to see you again. John's joining us from Georgia. Ahmed, where are you joining from? Ooh, Ahmed's joining from Egypt. That's cool. So I don't have any books that I'm studying with, but if you go to the NCEES website, which is the organization that publishes and handles all the registration for the FE exam, they have some practice exams online and paper, and they also have I think that's it. But those are really good resources. I think if you're just starting to study for the FE exam, it's good to purchase one of those practice exams so that you can just sit down for 6 hours, take it, see how you do, so you know what areas that you are really good in and what areas you need to focus on a little bit more. Okay, still working through this iPad issue. It always does this to me. Mm. I will get this resolved here shortly, just giving some people some more time to join. And once I figure out this iPad issue, I will start sharing my screen. But yeah, anyone have any fun plans this weekend? I'm gonna try unplugging, replugging it in. And I'm really happy to be able to provide you all with these free FE prep sessions. But if you do need some extra assistance, or if your test is coming up and you just want a tutor to study with privately, let me know. I also do private tutoring. So, yeah. I love technology so much. It is the best. So Ahmed said that he's a civil engineer with 5 years of experience, and you need the FE exam to travel to Saudi Arabia. I did not know that. What kind of engineering do you do? Like, are you structural or civil, electrical? Cool. Ahmed does site and technical office. So if you're just joining, we're about to get started. I'm just having some issues with my iPad and sharing it on the screen. Okay, it's working now. John, who's joining us on YouTube, says he's a civil engineer in traffic operations, and he has 4 years of experience in traffic ops and 4 years in construction. Awesome. Okay, it's working, but it's still being weird. Was anyone able to join yesterday, or is everyone joining for the first time today? I've noticed Thursdays, typically there are more people who are able to hop on, so that's good. All right. I think we're just going to have to work with this for now. Want to be respectful of y'all's time. Um, it's just gonna look like this. It's not letting me move my iPad screen, but that's fine. Okay, can you all see my screen? Again, if you're joining on TikTok to see my screen, you'll have to join on YouTube. But yeah, let's go ahead and jump into it. So make sure you have your calculator ready and your FE reference manual. Today we'll be going through two geotechnical problems, one on square footing, one on the phase diagram relationship, and then we'll be doing a statics problem. So yeah, hope you guys are ready to get started. Problem number one says that a square footing supports a steel column. The footing has a width of 2 meters and is placed at a depth of 1.5 meters in clean, medium dense sand. The groundwater table is at the ground surface and stays there year round. Find the ultimate gross bearing capacity in kilopascals and allowable bearing pressure. So, if you're preparing for the FE, you'll need to go ahead and start getting yourself familiar with the FE reference manual, which has basically all the formulas that you'll need to utilize on the exam. So let's see if I can open that up. So it is a searchable PDF. So I'm going to go ahead and search geotechnical to bring me to the geotechnical session. But you could also search like bearing capacity or something like that to get you there. But yeah, this is the FE reference manual. Um, the question is asking us to find the ultimate bearing capacity as well as the allowable bearing capacity. So we're going to be using this ultimate bearing capacity equation. So I'm going to go ahead and take a snip of that. Alrighty. So the ultimate bearing capacity is going to be equal to all of these very fun variables. Um, so yeah, we are given a couple helpful pieces of information. As you can see, the square footing is drawn here over to in the top right. So we have a couple knowns also written underneath that. But before we dive in, we're going to need to find the effective unit weight. So like the problem says, the groundwater table is at the ground surface, which means that all of the soil is saturated. So in order to find the effective unit weight, we are going to need to solve this equation. We're going to have the saturated unit weight minus the unit weight of water. So that's going to be 20 kilonewtons per meter cubed minus the effective unit weight of water, which we all know, or if you don't know, you should memorize it just so you don't have to go looking these things up during the exam. It's going to be 9.81 kilonewtons per meter cubed. So also, these sessions are way more fun when you all are participative. So feel free to put the answers in the chat as we go through. just to make sure you're testing yourself and that you're getting yourself comfortable with the material. There are no wrong answers. This is a safe space. It's just important that you try. So 20 minus 9.81 equals 10.19. So the effective unit weight for the soil is going to be 10.19 kilonewtons per meter cubed. Okay, so now we need to find the surcharge at the base. So that's going to be Q equals the effective unit weight times the depth of the footing. So we are looking for this value here. Well, these multiplied together is going to be that value. So DF is going to equal the depth of the footing, which is 1.5 meters. C is given, so let me start checking these off so we can see what factors that we already have. So C is given, and C is given, which is the bearing capacity. Let me go back to the reference manual. NC is the bearing capacity factor for cohesion. N of Q is the bearing capacity factor for depth, and N sub gamma is going to be the bearing capacity factor for unit weight. Okay, so we have C, we have NC, we found the effective unit weight, we have the depth of the footing, we are given a Q as well. B is going to be the width of the footing. So that's given in the problem statement as 2 meters. So we have that as well. And then again, we have N of gamma that is given. So we're going to plug all of that into the equation. So Q ultimate, which is the ultimate bearing capacity, equals C, which is 0. But let me just write it so you all can see. 0 times 0 is 0 plus 10.19 times the depth of the footing, 1.5 times n sub q, which is 18.4. Again, these are given right here. There we go. 18.4 plus 1/2 10.19 times 2 times 15.7. All right, so if you're following along, go ahead and type that on your calculator. And yes, Winston, we are on YouTube as well. TikTok Live does not let me share my screen, so you can search Degree to PE on YouTube and join us over there. Looks like we have 5 people joining us right now. Thank you for liking the live. That is very helpful because I think the algorithm pushes it out to more civil engineers. So, okay. So if you are following along, you can go ahead and put the answer that you got in the chat. I'm going to go ahead and type this in on my calculator, but you guys can make sure that I'm getting the right answer. And this is good practice because the better you get using your calculator, the faster you get at using your calculator, the faster you get to go on the exam. On the exam, you're going to have about 3 minutes per question, so you want to make sure that you're able to answer these questions in 3 minutes or less. So feel free, if I'm going too slow, to work faster than I am, but I am getting, yes, 441, thanks John, 441.2 kPa. All right, So we found the ultimate bearing capacity, which was the first part of the problem. But now we need to find the allowable bearing pressure. So to find that, we're going to be using, so ultimate is obviously the most, the force that the soil will be able to withstand. But obviously when you're designing things as an engineer, you don't want to go to the all the way to the end of the spectrum. You want to account for some factor of safety just in case geotechnical conditions aren't exactly as they were at the time the geotechnical survey was done. So the Q allowable is going to be equal to the ultimate bearing capacity divided by the factor of safety, which is given over here. So the factor of safety is 3. So we're going to do 441. Hey everyone, if you're joining on TikTok, make sure that you hop over to YouTube Live so that you can see my screen and work with us through practice problems. But yeah, 441.2 divided by 3. Anyone want to share what they got for that? Yes, the information on the right is given. So all of this. Anyone good at mental math want to share the answer? So I am getting 147.1 kPa. And let me highlight these in yellow so that we know what our answers are. So that's the answer to the first part of the question. Oops. And this second equation here is the answer to the second part of the question. Nice, John. Yes. All right, so that's it for the first problem. Let me know if you have any questions. I'm going to go ahead and move on to the second one, which is going to be a phase diagram problem. So staying in geotechnical, personally, geotech was not my favorite class, but on the FE, it's very important that you have a good understanding of geotechnical concepts. On the PE as well, there's a lot of well, there used to be, but they just changed the test format earlier this year. So let me check the chats to make sure there's no questions. Thank you all for joining. Make sure you like the live and share with your civil engineering friends. So I go live Wednesdays and Thursdays from 3 to 4 p.m. Central Standard Time. So yeah, happy you all could join today. All right, so the second problem is going to be going over the soil phase relationships. So let me grab a picture so we can all see it. Copy image, pasting the image. Ooh. Okay. And I'm going to try to get through more problems than I have been. Like yesterday, we only got through 2 in an hour. And I feel like you all need to see way more problems than that. So we're going to try to move these along a little faster so you guys can get more practice. Okay, So the second problem is going to be geotechnical. So as you all know, soil is made up of more than just soil particles. In soil, there's also water, there's also air. So this diagram basically relates the volume of those three components to the mass. So get really, really, really familiar with all of this. So I'm just gonna write this out. So a soil sample has a total volume of 0.05 meters cubed. The total, actually, I'll just write it here. Some other givens, the total mass is 85 kilograms. The mass of water is 25 kilograms. And the specific gravity of solids, which is G of S, equals 2.7. All right. So we need to determine I really did not like these types of problems in college, but very important for these exams. I have never used it on the job, but I've definitely seen it on the exams. So first we want to find the void ratio. And again, if you go to your reference manual, you'll see all the formulas that you need. We'll get there in a second. Hi everyone, if you're joining on TikTok, make sure you hop over to D2P's YouTube page. I'm also streaming on YouTube, and on YouTube, I'm able to actually share my screen. So you will see more than just my face if you join on YouTube. We also want to find the degree of saturation. And I'm also trying to make these problems more multi-step, just so we can practice a couple of things in one problem. But on the exam, this could be, multiple problems. We also want to determine the water content and the porosity. So this will give us practice finding these 4 items. Okay, so let's find the mass of the solids. So to find the mass of the solids, we need to, let me write in a different color to show that solving. Let's do brown. It's geotech. So M of solids is going to be equal to the total mass minus the mass of water. So that's going to be equal to 85 minus 25 equals 60 kilograms. Okay. Continuing, hopefully you all have something to write with and you have the problem written down, because some parts of the screen will get cut off as I scroll. Okay, so now that we know the mass of the solids, we want to find the volume of the solids. So again, make sure you're looking at your reference manual. I'm going to pull mine up so I can also look at it. Geotech. And if you just search geotechnical engineering, the phase relationships diagram is going to be the first thing that comes up. Okay. And phase relationship problems, they just take practice. So even if you aren't really comfortable today, the more practice that you do, the better that you'll get. Okay, so now we're going to find the volume of solids, which is going to be the mass of solids divided by the specific gravity of the solids times the density of water. Hey everyone, if you're joining on TikTok, make sure you hop over to YouTube Live so you can see my screen as I work through practice problems. But yeah, TikTok does not let me share my screen for some reason. Okay, so that's going to be 60 divided by, we were given the specific gravity, so that's 2.7. And then we're going to multiply it by the density of water. Again, that can be found in your FE reference manual. It's 1,000. And once you multiply all that together, make sure you can still see this. Okay, you're going to get 0. Let me 60 divided by 2.7 times 1,000. 0.0222 repeating meters cubed. So now that we have the volume of we found the mass of solids so that we can find the volume of solids, which is going to help us find the volume of water. So we're not accounting for air because the problem, well, nothing's given it for air in the problem. So the volume of water is going to be m, the mass of water, divided by the density of water, which equals 25 divided by 1,000. Which equals 0.025 meters cubed. Because we're still working on number 1, determining the void ratio, and the void ratio is, according to the FE reference manual, it's going to be the volume divided by the volume of solids, which tells us basically how much. Let me specifically look up what the void ratio is. The void ratio is the volume of the voids to the volume of the solid. So voids will be air and water. So that's what VV is. If we look at the diagram, I know it's hard to see, but this right here is the volume of the void. So that's going to be air and water. So this is what we are trying to get to, which is why we're going through this exercise right here. All right, so we have the volume of solids, the volume of water. Let's keep walking through. So now that we have that, we can find the volume of the voids. So the volume of the voids equals the total volume, V total, minus the volume of solids. So Vs, that's going to be 0.05 because that was given in the problem statement right here. And we're going to subtract the answer that we found, 0.0222 repeating. Feel free to put the answers in the chat once you have the volume of the voids figured out, which is going to be 0 0.0278 meters cubed. So, void ratio, that's the first thing we want to find. So we need to figure out what the volume of the voids was. We need to figure out the volume of the solids. We have both of those pieces of information now. So we can go ahead and solve for the void ratio. So that's going to be 0.0278 divided by 0.0222. And we're going to get the void ratio is equal to 1.25. How'd you guys do? Did you get that one right? Any questions on that so far? So we found the answer to the first one, void ratio. All right, so now let's work on the degree of saturation. Degree of saturation. No worries, John. This will be multiple choice, so this one I did not set up as a multiple choice problem, but you'll be able to compare your answers to the answers that they give on the exam. So that should help you out. All right. So degree of saturation, again, going back to the reference manual. And let me pull it up on here so you guys can see that it's really in there. Really all the information that you need. So I'm just going to search saturation. 26 results. Okay. I'm going to go back to the geotech. Okay. I searched voids and that gave me less results. Okay. So we're back to the phase diagram in the FB reference manual on page 259. We just found the void ratio right here. Now we are going to solve for the degree of saturation. It gives two different formulas that we can use. So let's go ahead and determine which of those would be best. Gonna change to blue. Degree of saturation. Alrighty, I'm gonna paste those formulas. So which of these formulas would you guys like to use to solve this problem? The first one or the second one? What factors do we have? So we have everything that we need for this first one. So that's the one that we will use. So S is going to be equal to the volume of water, which we found to be 0.025, divided by the volume of the voids. Ooh, my light turned off. Okay, it's just going to be a little bit darker in here. All right, so volume of the voids is going to be 0.0278. What are y'all getting? Times 100. Sorry, forgot that part. So this would be a relatively easy problem on the exam. Yes, John, you definitely want to use the first one. Times 100. So for degree of saturation, I'm getting 89.9%. And let me just tell y'all what the definition of the degree of saturation is. So the degree of saturation is the ratio of water to void space in a porous material like soil. which ranges from 0% to 100%. So if you're getting a negative number or more than 100%, you know you went wrong somewhere. All right, so we solved the second one. I'm just going to box these answers in so it's more clear. Okay, we found the degree of saturation. Awesome. So 3, we need to find the water content. So I'm going back to the FE reference manual. Lost my place, but that's okay. Geotech. There we go. Okay, so we just found the degree of saturation. Now we are trying to find the moisture or the water content. So that equation is given right here. I already used blue, so I guess I'm going to use orange. So let me get this, copy, paste it back here. So 3, we're trying to find the water content. That formula was given in the reference manual as follows. So the water content is going to be the weight of the water divided by the weight of the solids times 100. All right, so sorry, let me see if there was another equation there. Geotech. Okay. Water content, yes. So, yep, weight over weight. But you can also do so we know weight is the mass of something times gravity. So obviously the weight, the gravity, the coefficient of gravity is going to be the same for both. So you can also do the mass of water over the mass of solids because you'd have mg over mg, the g's would cancel. Does that make sense? All right, so so we already know the mass of each times 100 because it's given in the problem statement. Let's go ahead and make this orange. Okay, so we're given the mass of water is 25 kilograms. That's a mass. And the mass of solids we found in the first part of the equation. Air does not have a weight. So that's why it's just the mass of the solids. So the mass of solids we found is 60 right here. Okay, just making sure you guys can still see this. So 60, we're given the mass of water is 25. So we will do 25 divided by 60 times 100 equals, feel free to put your answers in the chat. We are getting, or times 100, I keep forgetting that part. I'm getting 41.7%. So hopefully you're getting the same thing. Let me know if you're getting something else. Yes. John, you did the same thing I did. Cool. But good catch. All right, and let me just add one more page because we're not done with this problem quite yet. So lastly, the question is asking us about porosity. Purple. We'll do porosity purple. Okay. 4. Does anyone want to give us the porosity equation in the chat before I go look it up? Don't be shy. So porosity is known as, or is denoted as N. So I can go to the reference manual. Keeps kicking me out of the geotechnical session. Okay. So here's the porosity equation right here. So we can do the volume of the voids over the total volume, or we can do the void ratio divided by 1 plus the void ratio. Whichever one we want to do. Yes, whichever one you really want to do. Hopefully you calculated the void ratio correctly on the exam so that you can use it, but you can also use the volume. Let me take this. Yep. Okay, I'm just going to write it out. So N equals the volume of the voids over total volume, or the void ratio. Thank you, John. I love how you respond to all the questions. You're going to do really well on your FE exam. Okay. So let's go ahead and use the void ratio. So we got 1.25 divided by 1 plus 1.25. And we're going to get 1.25 divided by 1 plus 1.25. No multiplying by 100 this time. So I'm getting 0.55. We'll round to third decimal. But again, this is a multiple choice exam, so you'll just pick from the best options given. But yeah, so I know that was only the second problem, but it was a multi-part problem because I wanted to just give us some more practice. We haven't hit geotechnical yet. We were going to hit it yesterday, but we ran out of time. So yeah, we did 2 geotech problems in one day, and we'll continue to practice these, but hopefully that helps you guys feel a little bit more confident in geotech. Any questions about that problem? Cool. Okay. So let me go ahead and set up this last one. So we can either redo the engineering economics problem that we did yesterday, but I made it so we could use the interest rate tables instead of the formulas, or we can continue the statics problem that we were doing yesterday. Does anyone have a preference? Engineering economics or statics? Which one would you like to see? Let me know. And if there are any questions that you want me to go over next week, there is a link in my going live video post that you can submit practice problems to. So if there's a practice problem that you want to see someone work through, not have to go look up on Chegg and pay for your Chegg subscription, you can definitely submit it to the Google form that I have, and I will work through it for you. Chegg has gotten it's so hit and miss sometimes. Sometimes the answers make a lot of sense, and sometimes they don't. And some people's handwriting, very hard to read. Okay, so John said statics, so that's what we're gonna do. Okay, so we did start this yesterday, so I'm just gonna copy and paste what we did so far, and then we can just continue to work through the problem. So in member, I'm just going to label what we got. Let's see, I'm going to grab this, copy, paste. So y'all can see what I'm doing. I'm just grabbing what we completed yesterday. We found the force in 2 members, I believe. And then I think we ran out of time. So we can just continue on with this one. All right. So erase this. Okay, so we found the force and whether the members were in tension or compression yesterday for this member here. We started at point D because when you are solving problems like this using, we were using the method of joints. So when you're using the method of joints, you want to make sure that you're starting at a location where you have at least one known force and up to 2 unknown forces. So we only knew one force at D, so we started at D. We saw for member CD, and we saw for member DE. So let's continue to joint C, because now we have one known, which is member CD, but we don't know the force in CE or CB. So when you're using the method of joints, like I said, you want to start at a location with at least one known and one unknown. Oh, and up to 2 unknowns. And it's up to 2 unknowns because we only really have 2 equations of equilibrium that we're using during the method of joints, and those are the sum of forces in the y direction is equal to 0, and the sum of forces in the x direction is equal to 0. Okay, so we are going to start at C, so I'm going to go ahead and draw the free body diagram because that is the next step in the method of joints. Draw the free body diagram. Of joint. All right. So we're going to do joint C. Let's make it purple. Really feeling the purple today. All right, so this is joint C. What forces do we have at joint C? So we have this known force here, FCD. We have an unknown force here. That looks symmetrical, right? So this is going to be FCE. And then we have one going. And for the unknown forces, you're really just assuming the direction that they're in. But as you get better with statics problems like this, I'm actually going to draw. You get better at assuming what direction the force is going in. So I'm going to assume that FCE is going towards the joint C, and I'm going to assume that the force in member CB is going to the left. But the answer that you get will let you know what direction it's going in. If you get a negative answer, you know the force should be drawn opposite of how you have it drawn. Okay, so next thing we want to do is be able to break our forces down into their x and y components. So make sure you know what the angles are that you're using. So that's 60. This one is also 60. So that's 60 and this is 60. Well, we don't really need that one. Okay. So, assuming that we all know how to break forces into their x and y components, now we're going to solve for our equations of equilibrium. So, the third step is solve for equations of equilibrium. All right, so do we want to start with summing the forces in the x or the y direction? Does anyone have a preference? I think it's going to be easier to start in the y direction just because we have a known force. The only two y components are in force CE and CD. So we're going to sum the forces in the y direction. We're going to say up is positive. Sorry, it's trash day. If you all hear any noise, that's what that is. Okay. So we know the force in CD is 9.24. And again, yesterday we solved for this and we said it's in tension. So whenever a force is going away from the joint, that is telling us the member is exerting an equal and opposite force towards the joint. So the member is doing this. So, and it's going to do that on either side of the member. So if the member is being pulled on each end, that means it's in tension. And if it's going towards the joint, we know the member is in compression. So that's why I drew force CD like this. Okay, so we know force CD is 9.24, but we need to multiply it by the cosine. The cosine. So this is also 60 degrees. Or sorry, the sine. Times the sine of 60 degrees. Because the y component is opposite of that angle. And we are going to, and it will be negative since the y component is going downwards. So negative 9.24 times the sine of 60 degrees plus a force CE that we do not know times, again, the y component is going to be this. We'll make it dashed. So it's going to be up. So positive sine of 60 all of that equal to 0 because we're in equilibrium. You can go ahead and solve for the force in member CE and let me know what you get in the chat. I'm going to go ahead and type it in on my calculator. And obviously you're going to get FCE is also equal to 9.24 kilonewtons. And is it in tension or compression? Because that's also a part of the problem statement, what the problem is asking for. So the force is going towards the joint, but we know the member has an equal and opposite force. So member CE is going to be in compression. All right, and so now that we have um, the force in CE figured out, we can easily solve for force CB by doing the sum of forces in the x direction equal to 0. We'll say anything to the right is positive. You can always change the direction system as you go through, but I'm just sticking to the traditional up is positive, right is positive. So sum the forces in the x direction, we're going to have negative force in member CB. Okay, plus the x component of force CE, which is going to be 9.24 times the cosine of 60 degrees. And let's make it black. Okay, and then plus 9.24 times the cosine of 60. So that's for force CD, all equal to 0. Now you solve for force in the member CB. It's going to be 9.24 times the cosine of 60 times 2, basically. And what do you know? You get we are going to get 9.24. Let me know if you all are getting the same thing. FCD, John is asking if that would be positive or negative. So I assume positive since if I draw it like this, let me make it dashed. It's going to the right. Same thing for CE. It's going up and to the right. Does that make sense? Or did I miss something? Let me know. I am human. I can also make mistakes. But I'm pretty sure that's right. Okay, cool. So 9.24 is what I got for force in the force in member CB. So 9.24 kilonewtons. And is that member in tension or compression? So the force is going, because we got a positive number, we know the direction which we drew the force in member CB is correct. So it's going away from the joint, which means the member is opposing that force with an equal and opposite force. So force CB is also going to be in tension. So we solved for these two yesterday, and today we solve for these two. So yeah, on the FE exam, they're not going to give, I hope they don't give you a problem like this because it may take you longer than 3 minutes because you have to keep doing these equations over and over in every joint. But yeah, this is a good practice problem just so you can keep practicing those equations of equilibrium, the method of joints, and yeah, eventually you'll be able to figure out what the reaction forces are in this pin E and pin A, or E actually looks like a roller, so Yeah. But you just keep doing that same method until you find it for each member. But yeah, I think that's enough of this statics problem. But if you want some extra practice, you can always keep going, figure out some of these other members that we still don't know. And then sometimes you also have zero force members, which are members that don't have any force in them. So definitely want to make sure that I do a problem like that in the future. But I don't think we're going to hit this problem again next week. So good practice though. And again, if you weren't able to join today or if you had to hop off early, you can always go back and watch these live videos later. This is our sixth session, guys. And yeah, we've gotten some practice in, but want to make sure I'm hitting the different topics if you're preparing to take the FE exam this semester and you want real life practice. But that is all I have for you guys today. Sorry for the technical issues at the beginning. I need to log on earlier next time to make sure we work those out so we have more time for problems. But yeah, you can always message me on TikTok, on YouTube. You can leave a comment, LinkedIn, Instagram. If you need help with anything, I'm really happy to help. I do this full time. I give private tutoring sessions as well. So, yeah, just let me know if you need help. I want you guys to succeed. I know how overwhelming these exams can be. So, just want to help out my fellow civil engineers. But that's all I have for y'all today. And I will see you guys next Wednesday at 3 p.m. Central Standard Time. I hope you guys have a good weekend. And yeah, I'm going to log off if there's nothing else. Thank you for liking the live. Really appreciate it. See y'all next week.